Hey, my name is Ruturaj and she is Aisha. And today we'll be discussing about a final project which we did for this course. And the summary of this project is first we'll just be talking about the what is project management. And project management is basically, as you can see here in the image, it is management of all three aspects, which is cost, time and quality, and also keeping in mind the project schedule and everything else. We get all this done in the right direction will lead towards profitability. And project in this project we have done some analysis which includes cost estimation, cost histograms, WBS, which is breakdown structure, network diagram, Gantt chart, resource allocation, and resource leveling. And we have also done some earned value analysis. And the our first focus area is, first I'll be just walking through a story behind name of a company, which is Ruturaj and Aisha Associates. And basically this name is because uh, I and Aisha both are from different backgrounds, and I'm from construction engineering background, and she's from architectural backgrounds. We have both the brains in this company. Second task which we did for this project is we just calculated the cost which is required to build a building which is situated in Oklahoma, and the plan was to build the same building in Texas, Dallas, or St. Louis. And for that we needed which was given in the question. And we for this we needed to do the location adjustment factor and size adjustment factor. And from that we just calculated the project overall project budget for Dallas and St. Louis. But the thing is, for pro- for project management tasks and contingency tasks, we cannot use location factor and size factor, because the location and size does not affect the overall cost that much in case of contingency and project management. But although some people do not recommend using location factor and size factor for on-site work, on-site utilities, and procurement, but I preferred using it because I believe these are some important factors. And for example, if you are using water as a on-site utility, and so basically water in Oklahoma City is a lot cheaper as compared to Texas, Dallas, and there it will be costlier. So location and size might matter over there.
So now for focus area 2, from table 2, we have like the activities, duration, and it's listed the activity duration and the successors. From that, we created work breakdown structure that represent start to finish for each activity. We're starting from activity 5 to activity 300. So this is the activity and node diagram showing critical path. We get this one from Microsoft project. It's from the activities, the duration, the early start, early finish. This is what we found. Uh, we have also the total float and free float. So whenever there's zero, you can see that critical path is showing the red line. Okay, so this one is the timeline, showing like duration for each activity and how many days each activity is gonna consume. So from this one, we can see like the first activity is starting April 6, 2020. And of course, the red line is showing like the critical path. This one is also a timeline from the activities, and from this we can see like the end of the activity, which is uh, uh, the project should be finished at July 13, 2021. Okay, so from the data from the next the task before, we found the late start and early start, and from that we create an histogram of weekly costs for the project. And as you can see from the x-axis, there's a date for each weeks, and the y-axis is the cost, how many each week's gonna cost for the project for each task. Yeah. And this one is the weekly cost versus the time curve. As you see, the blue line is represent the accumulation of early start, and the orange line is represent the accumulation of late start, and the gray is the target for the project.
So the final two steps are uh, allocating the resources, and allocating the resources basically means that we are just applying the resources which we have in which might be in terms of workers or material. So for this particular case, we'll be using workers, and we'll be using 30 workers for this project. And as you can see, we have just entered the 30 workers over here. And but the problem is there is sometimes over allocation of the workers, and this red red dots or red people show that over here there is over allocation. And even this graph shows in the red it shows over allocation, and blue is like within the limit. Basically this means that we have the resource limit of 30 workers per day, and it is just exceeding that limit. To fix this problem, there is one feature, or there is one method called resource leveling. We can do it manually as well on a paper, but for this particular project we have used Microsoft project. And we just have to enter some steps, some details, and just click on level level all. But the thing is, in my case there was some error, and it just fixed this area over here in the Gantt chart. It fixed it, but in the uh, resource leveling graph it did not fix it. It just fixed two of the dots. But I don't know what was the problem, because I even had a word with Mayawa, and even he tried fixing this. I had word with my couple of my friends, but uh, I'm not sure. But I'll just try to fix this, and once I'm done with the like correction, I'll just try to re-upload the corrected file.
And the last task was earned value analysis, in which we were supposed to find out the BCWS, BCWP and ACWP of the project. BCWS is basically the cumulative amount of the week by week or cost by cost distribution chart. And from this type of chart we just got BCWS, which is this amount. And BCWP is basically I just multiplied this percentage complete by the cost, daily cost or weekly cost, and from this we got this values. And this is the summation of this entire thing. And from that, this value is BCWP, and ACWP is summation of the actual cost.
So this is all we have. Thank you.
Thank you.